All right, let's talk about part one, why permissions matter for RAG applications. So we've seen a trend right now that models are more or less becoming commodities unless you're OpenAI or Anthropic or Google and you're building, LLMs from scratch and finding tuning them exactly to what you want. You've probably seen a UI like UI is getting more popular where you can actually pick the model that you want. And generally, you're picking sort of the frontier models that are coming out of Anthropic, OpenAI, and Google. So models now for most AI applications are more or less commodities. And what we've actually seen now when we go on, say, ChatGPT or Claude, is that connectors are becoming the next domino to fall. So this is a screenshot actually of Claude, and you can see that they allow a lot of connectors to different third-party platforms that their users use. And the reason behind this is pretty simple, right? Like if models are commodities and sort of that model capability is commoditized, then the next step to improve your AI application is actually get better quality data. And that better quality data usually lives in third-party SaaS tools that your users use, like Gmail or Google Drive or SharePoint. So to give another concrete example, we've seen Cursor already start to build integrations, and they've built integrations with GitHub to better understand code bases and Slack to actually trigger agents. And we see a world where they'll just keep scaling those integrations. Why not keep, plugging into tools that their users are already using, like Jira, like Linear, like Confluence to pull documentation, read specs, pull, information from ticketing context and just get more, ingrained in their user's workspace. And all of this at the end of the day is RAG, right? If you're retrieving, say, statuses of pipelines of like Jenkins and like CI/CD pipelines from GitHub, that's essentially, retrieving external context and allowing your LM to have that context to have better quality responses or better quality actions. So integrations and being able to essentially perform RAG on third-party systems is just becoming more and more popular and more useful and essential to your application. So how do permissions come into play, right? And if you're going to be able to retrieve external context from third-party platforms like Google Drive, then you better be sure that you're also permissioning on that data correctly. You're correctly, returning that data to authorized users. So a simple implementation that we've seen and that we've built for ourselves is we built sort of a ChatGPT-like application that's able to plug into Google Drive. And so if you're a user like Chad and you're asking about sales performance, you should be able to get data that you have access to that, you're authorizing Google Drive to have. But if you're an unauthorized user, you're not Chad, your AI application should not surface data that only Chad has, that only certain users have, despite having that data in, say, your vector database. So at the end of the day, it's when you have an application production, you're building for teams, you're building for enterprises, having permissions and being able to only return data in your LLM, in your AI application to authorize end users, that is absolutely essential. And that's the whole reason we're in this webinar today. All right, now to part two. Before I go in, that was sort of an intro, so I don't expect too many questions, but I will check the chat real quick. All right, looks like we're good. Yeah, that's sort of just setting the stage. So we'll be talking a couple strategies that we've seen and actually implemented for ourselves in terms of ways to enforce permissions and implement a permission system for a RAG system. So the first method, and I think it might be the first method that sort of comes to mind when you're thinking, how do I make sure I'm enforcing third-party permissions like Google Drive permissions when I retrieve data? And the first method is using tools to actually go straight to the third-party API. I won't talk about, what goes into tools too much because I imagine a lot of the audience already knows. But if you don't know, I'll give a really brief introduction on what a tool is. But it's essentially an interface to give your LLM application the ability to run code that your developers have put together. So how this works is if you look on the right side of the screen under JSON metadata, you generally give your LLM a description and a name so your tool knows when to use a tool. So if you have a tool like querying Salesforce, you give it a description like use this tool when the user asks about Salesforce contacts or deals or leads. And then you give it inputs on what should go into the actual parameters of the code. So you probably want maybe a record type, like I want to search for contacts versus leads, and maybe filters like a time frame. So when one of your users asks, hey, tell me about my Salesforce contacts, the LLM knows, hey, I can use this query Salesforce tool, and I know that I need to pull record type and filters from the user query. So they asked about contacts, that should be record type, and filters could be like contacts from the last year. And then it takes those inputs, and then it runs a function that your developers, your engineering team will define. And a lot of times it'll be like calling a third party API or doing arithmetic or doing something that is better optimized for code than it is to use, let's say, like the LLM's natural capabilities for. And generally, like we could call a third party API, you get a response back. You give that response back to your LLM, and the LLM can answer the user's question using the third party API response. So it's really powerful. And you've seen actually, no matter how experienced you are with building LLMs, you've definitely seen examples of tools when you use ChatGPT or Claude or any just general chatbot. Whenever the chatbot says it's searching the web, it's actually calling a tool to scrape maybe like the Google search engine or Brave search. But it's actually using that tool to get the most up-to-date data, and it's actually performing RAG when you think about it, because that external data is not what it had in its original knowledge base. So when it comes to your enterprise application, you're probably going to want a third-party API like Notion's search endpoint or Salesforce's query endpoint. And that way, every time your user is asking for, say, Notion data, you can call the tool, go straight to the Notion API, return it back to the LLM, and the LLM will give it back to the user. So it's a very clean way to perform RAG. And let's talk about the pros and cons of this. I think you guys probably already see that the biggest pros is you're going directly to the source of truth at every prompt. So when I ask my LLM chatbot, what's in this Notion page, it's calling the Notion API, getting the most up-to-date data. It uses the most up-to-date, Notion permissions. And I never have to worry about, storing that Notion data, making sure it's up to date, making sure permissions are up to date. I'm always going back to the API and constantly, getting the most up-to-date data and permissions. Another thing is permissions is actually managed by OAuth. And so if I'm on, say, an enterprise search application and I've integrated, say, Google Drive, every time I ask about a Google Drive file and the LLM is calling the API, it's using my Google Drive credentials on my behalf. And so I can never, get Google Drive data that I don't have access to via the API because it has built-in permissions. And therefore, if I'm using a chatbot that someone else has built, they'll never be able to surface data that I don't have access to because they're just inheriting my credentials. The negatives on tool calling is that, if you use tools every day, like say on Cursor, you can see that sometimes tools can be unreliable. And we've actually done research on why this is the case. Imagine a scenario where you use like a Notion search API tool. That Notion search, it has to be like very resilient to typos. If I search for, say, like product management, but I misspell like product, it won't get the right results. And so using tools can be, very brittle versus vector search because it's using semantic search. It's very resilient to faults like typos, or if you don't have the right inputs to a tool, vector search is a much better, more resilient and flexible solution. Another thing that you're sort of beholden to if you're implementing tool calling is that many third-party APIs aren't optimized for search. One example is, Salesforce's query API, it has like a SQL-like language, and that is really, really good for search. Generally LLMs know how to write SQL, and so you're able to search Salesforce for a lot of different things very flexibly. But for Google Drive, there's no like Google Drive search contents endpoint, the only way for you to search contents is actually to like, pull down the raw binary contents, convert that to text, and then, search that yourself. And that's a use case that's better for, vector search and actually indexing to a vector database than calling third-party APIs, just because Google Drive's API doesn't have like a search contents or search files endpoint. And the last thing is inefficient prompt time retrieval. And what we mean by this is if you have a use case where you only have one or two integrations, or you can only respond with one or two tools at any given prompt, then using tools might be a good solution for you. But if you have an example where you support, say, like 10 different integrations, say like Confluence, like Notion, like Google Drive, and a user asks a very broad question where they're not specifying an integration, a third-party data source, they might ask something like, give me the status of project X. If your LM has to search, Google Drive, then Notion, then Confluence, this just scales, in a poor way, especially as you keep giving your LM, more tools, more integrations that it supports. So our main recommendation is if you've done your research and the third-party API has really good search APIs, and you're going to have a low number of integrations, or at any given point, you know exactly what tool to use, and you don't need to synthesize information from, say, 5 or 10 different tools, then tool calling provides a lot of pros, and you can minimize the cons that we mentioned here. All right. So if you remember the last couple cons with tool calling, it had to do with, vector search being a better solution than calling APIs and relying on tool calling. That's why the next three methods are all going to be centered around, actually indexing to a vector database and maybe what you traditionally think of when you think of RAG. So in separate namespaces, what we're going to do actually is we're going to take advantage of a vector database like Pinecone. And in general, like Pinecone, like AstroDB, like Qdrant, they have concepts of namespaces. And namespaces are just essentially partitions to keep your different tenant data separate. Tenants can be like whole organizations, like if you have an enterprise customer, or they can be individual end users. And in this method of keeping separate namespaces, what we want to do is keep every individual end user, give them their own separate namespace. So that way, when they, authorize their Google Drive or their Notion or upload, local PDFs, all their data is kept in their namespace. And when they interact with your AI application, it's only querying from that namespace. So it's a really simple implementation, and it comes with a lot of pros that we'll discuss. And it's basically using the vector database's built-in functionality, built-in namespaces, right? That's the whole idea of namespaces, to keep data separate, using that for permissions. And it's a really great, simple implementation that you can implement very quickly using the built-in, Pinecone APIs or whatever vector database you're using. Where this gets a little bit sticky, and I think what contributes to the cons, is that if you have a more team-oriented or enterprise-oriented customers, generally what you're going to have is you're going to have an admin of your customer, authorize data ingestion for their entire organization, their entire company's Notion, or their entire company's Google Drive. And when this happens, because your end users each have their own partition, it means each of that enterprise customer's employees will get their own partition. And you might be able to start seeing, where the cracks start to form. It's because you're going to have a whole bunch of data replication and a whole bunch of inefficient, data operations when data changes. So I'm going to quickly jump to this appendix slide where you can imagine that, your company might have a file like vacation policy, and because you're using separate namespaces, every single employee needs access to that file. That vacation policy will be replicated in every single employee's namespace. So that's data replication. It's a whole bunch of, just replicated data kind of for no reason. And second, what happens if that enterprise customer decides to change that vacation policy? All of a sudden, for each of their employees, for each of your end users, data needs to change there. So It's a whole bunch of, expensive data operations and inefficient data storage. And so we think, separate namespaces, it still has its place, especially if you have like a B2C type use case, or each end user has data very unique to them, like they're uploading PDFs and no one needs access to their unique PDFs. Separate namespaces is a good implementation. It's simple enough and it uses the built-in, database APIs. But if you're trying to support enterprise customers, large teams, we think this method, it sort of loses its luster after that. So we kind of know that, we want data ingestion, we want vector search, and that's why tool calling, is a little bit inflexible there. And we know that, keeping separate namespaces can be very inefficient. So what can we do about this, right? I think what we can do is on the vector database side, just keep it simple. Just keep one copy of every chunk of ingested data. But what that means is on the permission side, we need to keep track of permissions so that way every time we pull data from a vector database, we're able to reconcile some sort of database of permissions and make sure that the user has access to the chunks that they're retrieving. And so, how you might do this is you might know the concept of an access control list, but it's basically a method for securing resources like files or like records in a CRM, and then keeping a list of roles and allowed users to those data resources. And one way to implement access control lists or ACLs is using relationship database tables. And that's what we call ACL tables. So, how it works is when you're ingesting from a third party data source like Google Drive, you're ingesting the raw file contents, but you're also ingesting and indexing permissions to a database, storing those permissions in a relational database. And every time your users prompt your application, we're not only using the vector database, but we're also using our ACL table um, to check access to the chunks that's retrieved from the vector database. So there's a lot of pros for this, right? It's really good for simple permissions. And if you know the concept of data modeling, the word modeling is there because you want to model your database after the native permissions of what you're trying to store. So if you're doing something like Salesforce where permissions might be relatively simple, you might have a user has access to the contacts table or a user has access to a leads table. Keeping that in a relational database in a table format makes a lot of sense. And the second pro is that your engineering team no doubt is already familiar with relational databases. They no doubt know, you probably are familiar with like Postgres, with SQLite, with MySQL, and have probably been using it since college. So they're very in tune with it. They might have like a database modeling SME on your team, and it's really easy to get up and started with that. Where we think ACL tables and relational databases actually fall apart is despite the name relational databases, it's actually a little bit of a misnomer because they're not always the best at keeping track of relationships. And what we mean by that is if you have really complex permissions that have a lot of like parent-child relationships. So imagine, a team has a bunch of members and, a team might have access to a folder with a bunch of different files inside that folder. These are all sort of like one-to-many relationships. And there are other databases that actually map these relationships better. So I'll quickly jump to this. And if you kind of bear with me and look on just the left side with, the 5 tables on the left, this is one way to model, say, Google Drive permissions. You can keep a table of all your users, you can keep a table of all your folders, keep a table of all your files, and then create these relationship tables to see, what users have access to what folders, what files are members of what folders. And this is really good for writing relationships, right? Anytime a new file is added to a folder, it's just one record update in the folders to files. But where this gets really inefficient is reading. Every time you consult your database and say, hey, does Chad have access to, say, file 101, the report Excel? You have to do like a bunch of joins. This is like, 1, 2, 3, 4 joins just to get that information. So it's very read expensive, but it's very write efficient. On the other hand, if you look on the right side and you have a very simple table where you just have, all the files with a list of users that have access to it, this is very read efficient because, you just have to query is, does Chad have access to contracts.pdf? And you can just see the table and see that that he does. But it's extremely write inefficient because in an example where, say, a user Jack loses access to a folder, all of a sudden you need to update the record for every single file that's a member of that folder. So you can start to see, relationship databases, they actually map relationships in not the most optimal way, and you need to kind of struggle with these trade-offs on, whether you want to be read efficient or write efficient. Second con is actually webhooks and polling. If you want to store if you want to store permissions in a database, it means you better make sure those permissions are up to date. And so anytime a file, gets a user added or someone revoked, you need to make sure your database is in tune with those changes, and you need like webhook or polling infrastructure there. All right, so our last method, and then I'll stop for questions. If if relationship tables aren't always the best for mapping relationships, what's a better database type? And that's where we have permissions graph or a graph database. And so how graph databases work is it's very similar to, the initial steps of ingesting permissions for, say, like an ACL table. You're still going to ingest the third-party data into your vector database. You're still going to need to pull the permissions data from the API, but this time you'll store the permissions in a graph database. And you can see on, the sketch on the left, um, it's way better at modeling relationships as you would in, say, the native Google Drive permissions. And that's honestly the biggest advantage of using a graph database. And so the biggest pros, you're able to be very flexible and model hierarchies like those parent-child relationships that I just went over. It's way easier to model them in a graph database than a relationship database. And one really nice thing is because a graph database is a NoSQL database, you don't have as strict schemas, and you don't have, as strict constraints. You're able to actually be more flexible in defining different types of relationship types and keeping track of different types of data per node. And why this is really important is you can use one database to keep track of your Google Drive permissions, your Salesforce permissions, your Slack permissions, all in one database because, for a Google Drive, you might need, say, folder file relationships, but in Salesforce, you might only need, say, like user to object relationships. And you can define all of this in one database without too much hassle. The second piece is, unlike relational databases, read and writes in a graph database is efficient and you don't need to make a trade-off there. And so quickly to jump off that illustration of what I showed if Jack loses access to a folder, unlike the whole example where, you need to update a bunch of different records, all you need to do is update one edge and then you're good to go. And because graph databases are optimized for graph algorithms, checking, if a user Jack has access to, a Notion page, even if it's sort of like a multi-hop query, you need to track the, like third or fourth degree relationship. Graph databases are very optimized for that. And so you don't need to make that trade-off in terms of reads and writes. All right, and now to the cons, because there definitely are some. One, since graphs are more of kind of a niche technology, they're mainly used for like networking or social networking or recommendations. Your engineering team might not be quite as, adept and experienced at using graph databases, and it can get complex when you want to do things like have one relationship override another. It can get sticky. And the second con is, again, like ACL tables, anytime you're storing permissions, you need to make sure those permissions are up to date. So you need webhook or polling infrastructure to make sure that the graph database is actually reflective of the actual third-party permissions. So our recommendation here is permissions graph are a good option if you have a bunch of different native third-party permissions you need to keep track of. and if those permissions are relationship based, because that's the graph database's bread and butter. So in summary, yes, permissions graph we see in general, it provides the most flexibility. It allows you to use vector search to achieve the best RAG performance. It's efficient at data storage in terms of like you don't need to replicate a bunch of third-party data or third-party permissions. You need one copy only, and you don't need to make as big of a trade-off in terms of reads and writes. All right, that was quite a lot. So I will check the chat, and I'll give a minute real quick just to see if there are any questions. I think people are talking about like partnerships in the chat, so I'll leave that one alone and let other people in my team handle that. All right, we're doing pretty good on time. I'm gonna try to make this end at, say like 11:40 or 45, and then I'll leave the rest of the time for any questions that you guys have. All right, so our last part, we've kind of gone over all the options. You probably have noticed, we kind of prefer the graph-based permission strategy the most. So let me show you what that looks like. So, just keeping a permissions graph, it doesn't mean you have permissions or you've enforced access control. It just means you have a place to store permissions efficiently. And so how do we actually use that graph database in our RAG pipeline? There's three types of ways to read the graph database or query it to actually enforce access control. And so the first one is, based off a user, what objects does a user have access to is the first way. You can get an array of all the different object IDs a user has access to. The second type of query you can do is based off an object ID, what are all the users that have access to this object? And the last type of query is a true false Boolean type query where you just want to see, is there a relationship between a user ID and an object ID? And so even though, these three query types are returning different types of data, you can probably already start to piece together how this might work in a RAG pipeline. And so the first one is one we labeled as pre-retrieval filtering. And we call that pre-retrieval filtering is because we are going to check the graph database and filter for allowed objects before we retrieve the vector chunks themselves from our vector database. So what we're going to do is a user is going to authenticate and ask, a prompt like, what's the status of project X? Based off the user ID, we're going to get all the different object IDs they have access to using our graph database. And then what you can do is most vector databases like Pinecone support metadata filtering or some type of filtering operation. And so you can go to Pinecone and say, only give me relevant chunks with these object IDs. And so that way, unauthorized chunks never make it back to your AI application. And that filtering is done pre-retrieval. It's done before the chunks are retrieved from the vector database. The second option is post-retrieval filtering. And in this method, a user will still prompt. And instead of going to our permissions graph first, we're actually going to go to our vector database first and say, based off the prompt, give me all the relevant chunks, no matter if the user is unauthorized or authorized. From there, we will check our permissions graph and use that check access, or there's also like a batch check access endpoint where you can check a bunch of different object IDs and user IDs all at once. And then from there, we can see which chunks are allowed and which ones aren't, and only give our LLM, our AI application, the chunks that the user is allowed. So we call this post-retrieval because we're going to retrieve the vector databases first, and then we're going to enforce that access control using our graph database. And so what does this look like in code? What does this look like in your RAG pipeline? The first step is your API call to the LLM, giving your LLM the ability to execute RAG functionality. And from here, we're going to use Pinecone in this example with this retrieve context method. The query, we're just going to give it the user's question, And for namespace, in an enterprise application, in our situation, a namespace is just going to be that enterprise customer. We don't need to keep a separate namespace per end user, like per employee of that customer. So now we're going to double click into that retrieve context method. What we're going to do is we're going to specify a top K. In this case, we're just going to use a reasonable number like 5 chunks. And we need to make sure that we grab certain fields. And these are fields that are kept in metadata that most vector databases support. The one I want you guys to pay attention to is that native ID. That native ID is going to be like a file ID for Google Drive, or maybe a page ID for Notion, or maybe a record ID for Salesforce. This is how we're actually going to identify the object in our graph database. So this is essential that you keep track of, the native data provider's ID number. So once we have those native IDs, we're basically going to create sort of like JSON objects where we're going to pass in, user ID and object ID and relationship type like read access. And we're going to be calling that batch check access endpoint. So what we're going to get in response is essentially an array of JSON objects, and it'll just tell us if that chunk has a true or false, if we have access or not. And then we're just going to write a simple for loop and say, only give the LLM the chunks the um, where we passed that check, where we got that true Boolean response type. And so the end result is, going back to that example, authorized user like Chad will be able to retrieve chunks from Google Drive files he has access to, and unauthorized users, that data never makes it back to the LLM, so that response never gets recorded with those data sources. And so in summary, we set the stage in terms of why your AI apps need RAG in the first place and what permissions look like. We went over 4 different strategies for enforcing permissions, and we recommended permissions graph in general as sort of the most flexible, universal solution that will work in most use cases, especially if you're planning on building, a lot of integrations for a lot of different data sources. And lastly, we went over an example of using post-retrieval, where we're able to take advantage of the batch check endpoint to enforce permissions after we retrieve your chunks from our vector database. All right. Thanks for listening so far. I do need to give a quick plug to my employer and the people that pay the bills at Paragon. Um, Paragon, we kind of started all this research into permissions and RAG ingestion because a lot of our customers wanted this from our platform. But we were seeing that, our embedded iPaaS product at the time with workflows wasn't doing that 100% efficiently. And so we built a product called Managed Sync. And it's called Managed Syncs because it manages 2 parts of the RAG pipeline that's essential for it to work. So the first piece is data pipelines for RAG ingestion. And what that means is, users can easily spin up a pipeline like a Google Drive data pipeline for any of their users with just one API call. And what that does is Paragon will start pulling all of that user's Google Drive data from there. And not only are we going to pull that data, we're also going to constantly pull the Google Drive API and keep it up to date. From there, you guys, if you're building a RAG application, can call the Managed Sync API and actually just get the file contents immediately in a normalized format. And that normalized format is actually very useful because if you're building across an entire category, like you're building Google Drive and SharePoint and OneDrive and Dropbox integrations, you can treat the data will return to you will all look the same no matter what data source it's coming from. So that way you can reuse a lot of the same code you're using for your Google Drive ingestion as you can for a SharePoint ingestion. The second piece, and maybe what you guys are a little more interested in, is we're also going to manage a graph database for permissions. And similar to when you trigger a sync with just an API, that same API call means we're going to index and ingest all the permissions for whatever sync that you just initiated, like a Google Drive sync or a SharePoint sync. And then we're going to build a graph database on our end that you do not have to manage. You don't need to be like an ontology or like a graph database expert. We will do all of that for you. We'll make sure it's kept up to date. And then you can just use the API to call that batch check endpoint or that get users endpoint or that get objects endpoint. And so we're essentially managing a lot of what we're calling the integration infrastructure behind your RAG pipeline because, pulling data from a third-party API and pulling permissions from a third-party API, that's not really specific to your AI use case, like your legal platform or your enterprise search platform. Um, maybe the RAG retrieval part is more of your secret sauce, your bread and butter, all of the logic that goes in there. But you getting the data itself, that should sort of be commoditized, and that's what we're trying to do with Managed Sync. And yeah, thanks for listening to that. Now I'll just leave the last 19 minutes for any questions that you guys might have, whether it's about Paragon or whether it's about all the material that I covered beforehand. More than happy to answer any questions you guys have. Okay, our team is saying, oh, there's a Q&A section. Okay, but I see Hemant. Um, how scalable is this approach? Uh, if I can just follow up, which approach are you mentioning, Hemant? While you kind of answer that for me, do you extract ACL data, or do we have to create in on your platform? So if you're using Paragon, like our platform, we will extract the ACL data for you. But this webinar isn't just about using our platform. It's also, we've built this from scratch as well. And so, yeah, if you are building from scratch, you're building your own ACL table or an ACL like graph database, you do need to research the permissions APIs for each third party that you're going to. So Google Drive, they'll have like a get files endpoint, but they'll also have like a get permissions endpoint where you'll get returned in general like a JSON object that will say like the file ID and all the email addresses for everyone who has access to that file. Okay, so it seems, Hemant, you said ACL using graphs, how scalable? It's extremely scalable because, we mentioned that it's very read and write efficient. And you're going to just use your vector database to do your RAG retrieval and this permissions graph that's optimized for read and write. So we've seen this work really well, and a lot of our customers have already adopted this using the managed sync that I've mentioned before. But it works well with a lot of the customers, and we haven't seen any issues with using our permissions API products yet. Okay. Neil, I saw just seeing your question. Why do you recommend permissions filtering post-retrieval and not pre-retrieval? Well, the main reason why is actually like if you can imagine if a user might have access to say 1,000 object IDs, we just haven't tested the limits of how good like the metadata filtering on a vector database is. The larger your array gets. And so we're not saying that like pre-retrieval is a bad choice. We just think post-retrieval is in general like a simpler implementation. But at the same time, you can definitely use like pagination, for example, if you do want to do it pre-retrieval, which is not a bad option either. Also, thoughts on storing external permissions data as metadata in your vector database. Actually, this is funny. Someone asked this like internally on our team. We were wondering this same thing. Um, Yes, it is an option to actually store the user IDs of allowed users as metadata. But if you can imagine, like, what happens if you're storing a lot of Google Drive files and then folder permissions gets updated? Now, not only do you need to update permissions on every single like file record, but every single file probably also has like potentially like tens of hundreds of chunks, and you're going to need to update each chunk as well. And so we think, keeping a separate database for permissions is a little bit cleaner there because you only need to update, one or two edges in that example. Okay, back to Hemanth. Follow-up question: how is deleted content and associated permissions typically handled by customers? Yeah, good example. Or good question. So yeah, if you're building in-house, there are webhooks to detect, file changes, and one of the file changes is a delete endpoint. In a way, you are a little bit beholden to um, like the third-party API that you're working with. If they don't support like a webhook or like a file changes endpoint, honestly, what you're going to have to do, and what we've kind of unfortunately had to tell customers sometimes, is that they're going to need to um, pull all the available files or all the available like messages from that third-party API and compare it with what they currently have in their vector database to be able to detect, what things have been added or deleted. But luckily, I think the more popular third-party APIs like Google Drive and SharePoint, they will have like a file changed webhook or file changed endpoint that you can just pull yourself. Yeah, any thoughts on OpenFGA versus Permify for Zanzibar style implementations? I'm not really familiar with Permify, but actually OpenFGA is actually like, um, what we what it's what we actually built when we're building these like tutorial and this content from scratch. A lot of the endpoints we um, mentioned, like batch check, like get users and get objects, they're all ones that OpenFGA supports. And we know this is actually getting more and more popular. I think WorkOS is also, they have also bought like an FGA type technology because we've probably seen that, this type of technology, it suits the agent and AI use case really well because we're integrating so many third-party data sources. So yeah, a lot of our content is based off like OpenFGA and us playing around and testing that. I'm not sure about Permify, so I can't really answer your question fully there. Cool. I will check Q&A. Okay. I will just give one more minute in case any last questions pulls in. But Neil, I will check Permify just to see, what their implementation is, and if there's any advantages or like cost benefits there. Okay, I will just skim through the chat one more time, just to see if I missed anything. Okay, yeah, I think, yeah, if there's no other questions. Okay, one more. Is there a data model you recommend when using multiple data providers? Um, yeah, so in terms of like, you probably have, heard this ad nauseum, but we recommend like a graph database. And one reason why is like the schema is very flexible. So it's really easy to introduce new node types and relationship types. And this is very, unsimilar to a relational database table. So if you can imagine, like Google Drive, you might need to keep tables of like folder to file relationships, user to file, user to folder, team to folder, all these different things. You don't need to do all that, defining tables in a graph database. You can define the schema just one time. Certain relationships can actually be reused. Oh, I mean, in a graph database. Yeah, I mean, that's honestly one thing that, is one of the biggest benefits of having a graph database is because it strongly mirrors and is modeled after like the Zanzibar, the Google Drive native permissions. It works really well for like a lot of different file storage providers. And I think file storage providers is probably one of the most, complicated types of permissions because you have so many like parent-children relationships. And you can definitely map, all the different file storage integrations or all the file storage like third-party providers with the same relationship types. But I will say you might have to add certain relationships for certain integration providers. And just one example, that we kind of struggle with on our team is in Google Drive. You can, explicitly say if someone has read or write access, but you can also sort of like implicitly say someone has access by using this like copy link feature. And when you have things like that, that might be a feature where that's not available in SharePoint. And so that relationship type, it might only be implemented with your Google Drive permissions and not your other file storage. And that's okay, just because like graph databases are so flexible there. Cool. Alex, what are some of the most interesting permissioning use cases you've seen with customers? Perhaps with a chat type interface that connects to various MCPs, for example. Yeah, I'm trying to think. I think the one that pops into mind the most. Okay, sorry. Is I don't know if I'm allowed to mention this customer by name, but I'll just say someone's building like an enterprise chat application. And actually, before we built Managed Sync, we were talking with them, and they actually used this like ACL table where they flattened permissions to just like files and a list of users. And that's kind of what we modeled one of our, one of the methods and slides on, because we've actually seen this in production out in the wild. So that's why, all these methods, all of them can work. But, they mentioned to us all the difficulties they had with that. And seeing their actual implementation of using ACL tables in the wild, it's both like a testament to their team. But they also mentioned that like, they wanted to get off it if they could, because it can be such a huge headache to maintain that type of interface. I actually haven't seen like MCPs being used for permissioning per se. One thing that I'm really interested in just in the future is like a lot of MCPs are now supporting like OAuth authentication. And so, funnily enough, if you guys haven't visited like mcp.shop, it's WorkOS's example of like a OAuth implementation of an MCP server. And it's a really cool experience because once you integrate it, once you enable it in your cursor, it just opens up your browser and sends you straight to like a WorkOS login. And so it's like a really seamless experience where I don't need to go in like my environment variables or like my cursor configs and define my like hard code my API key. They're providing a lot better of an authorization example. And I think this might potentially open doors to, if you remember like method one, the tool calling, if tools and like third-party APIs get better and are more optimized for semantic search, and we have like better and better protocols for authentication, authorization, MCPs, that method one, we might have to revise these slides in maybe like a year or two and actually say method one is an extremely viable option, and we think you should use it, if the third-party API is good enough to use. Okay, and then I think this is the last question from Hemant. Other than governance and ACL permissions, are there other gotchas that one needs to be mindful of when implementing RAG in an enterprise setting? Um, yeah, actually, one thing that really comes to mind, honestly, is it's sort of RAG related and sort of not, is tool calling, I think, is going to become, just more and more um, on the forefront of a lot of, I think, like product roadmaps. And it's because like we've seen how useful tools are, but we've also seen if you give an agent or a RAG application too many tools, it's, the tool selection ability goes down. Um, and also, these tools at the end of the day, they take up like a lot of tokens. And so your context window might blow up, or just cost considerations, right? You're, sending tens of thousands of tokens when you don't need to be, just for like a hi there message. And so I think tool selection is an interesting topic. And that's why, I have an interest in, say, like the A to A protocol, things like that, is because tool selection and dynamically giving your agent or your RAG application tools is something that it's not only going to be very like good for your costs, like your bottom line and costs, but also your users to actually call the tools that they want to call. All right. Yeah, thanks so much for the questions. Honestly, these have been like really good questions. I think a lot of people on my team have been saying like, if you do have further questions, you can like reach out to the Paragon team. Feel free to email me as well. Maybe I can get like the follow-up email to have include my email. And yeah, appreciate everyone just for showing up and listening. Um, and have a great rest of your day. Thanks.